Today we will see the static structural analysis of cantilever beam. Its material is aluminum whose Young's modulus is 7E10, Poisson's ratio is 0.33. Its length is 110 and cross-sectional area is 10 by 1. Line pressure of minus 200 Newton meter is acting on its free-end edge, which is upper one, and from this analysis we will find out deformation and stress. So we will start with now ansys workbench. So we will open this ansys workbench. Then here we will get this view where initially we will select this static structural After selecting this static structural, we will get this list from where we will start with engineering materials. We will add here aluminum, which will be the material for cantilever. Now we will assign its properties. For that we will click on linear elastic option. From that isotropic elasticity, we will write here the value of Young's modulus and Poisson's ratio. So Young's modulus is 7E10 and Poisson's ratio is 0.33. So we will write that 0.33. After adding this material along with property, we will come to the project or main menu. So you can check here that material is added. So if you observe here, this aluminum is added here. Now we will come to main menu by clicking on project. Now we will try to complete geometry of cantilever. So after clicking on geometry, new window is opening. So on left side we are getting the status. So here this is the view related to geometry. Now we will start the sketching of cantilever. So initially we will select sketching option. So on left side we are seeing that. So here we are seeing the isometric plane. We will convert it into two-dimensional by using upper icon. Then initially we will use grid option. For that we will use setting option, grid on, snap on, major grid spacing 1, minor step again 1. So we will use units, default units. Then here this snaps per minor is 1. Now we will start our drawing by using draw option. Initially we will try to complete a rectangle which will fix the length of the cantilever. So we will try to complete this cantilever. Having length equal to that given dimension. (110). Thickness is 1. So here this length is fixed. Now we will try to extrude it, so that extruding depth will be 10. So that 10 is assigned here. Then we will come to again main menu. Then now we will assign material. For that, model option is used. So here this new window is opened. So remaining steps are shown here. So we will start with model. So by choosing that geometry we will get solid option. We will assign material aluminum. Then we will do meshing. So after pressing update meshing, that meshing will be completed. Now we will apply boundary condition. So initially we will choose fixed support. We will select one of the end surface of that cantilever. Apply. So that fixed support is finalized. Now at pre-end we will apply line pressure. Again static structural insert line pressure. So upper edge is selected from pre-end. Then its value. So in negative y direction it should be applied. So choose vector, pull down components. So y component will be minus 200 Newton per meter. So here we will write that value. Then again click selection. No selection is there. So we will click on that. Then that edge is selected and click on apply. Now that pressure is applied. So now we will give information related to output required. Insert deformation total. Again output required is insert stress, strain, stress equivalent. Insert. We have completed. Then solve. So solution is completed. So this is the total deformation. So here we are getting those values, the total list along with unit, red to blue, maximum to minimum. Similarly for equivalent stress. Also animation can be observed by clicking on animation. Values can be found out by using probe option. So at particular location we can get the values which we want to find out of total deformation and equivalent stress. So probe will be for specific values. Animation will give us that change in stress strain or change in deformation. So that can be visualized. So here we complete this assignment. Thank you.